Okay, welcome to 5D. We are starting our basic trig ratios. So we are going to figure out back triangles now. So our basic trig talks about Pythagorean Theorem. But first of all, we need to know how to name sides and angles. So this is just a quick review. When we name a side, we have two different ways we can name a side. It is named with capital letters, and it is the two angles that's in between. So if I wanted to label this side right here, it would be side A to B, or across from it is baby C. Now you're going to notice, since it was triangle ABC, all three letters, what are you noticing? I have all in a row, all three letters. So whatever side is in between the two angles, it's the letter that's missing. So what I mean by that is this. If I've got a different triangle, and I say this is G, E, and F, and let's say I wanted angle D. Well, angle D, if we talk about angles specifically, I could call him by one angle, or make sure he's in the middle. So he's going to be E to D to F, or F to D to E, as long as he's the middle letter. Yes, it means you guys are talking too. So, if I look at angle F, I would do the exact same thing. Angle F has to be in the middle. So he would be D, F, E, or E, F, D. Now, if I wanted to name the side, if I wanted this side right here, that would be side EF with capital EF, or I would name it baby D. Why baby D? Because it is across from angle D. And remember, all three letters have to be present when I name it. So it's either going to be EF or D. So that's how you name a side. One letter or two letters, two capital letters meaning the angles. So we're going to jump through and go through Pythagorean Theorem. So Pythagorean Theorem can only be done when we've got a right triangle. So that's what we're looking at right now specifically is right triangles. So in right triangles, you will always have one 90-degree angle, as we can see. Naming sides, we just went through this. Side AC, you're just looking for the letter missing, is side B. Side BC, look for the letter missing, it's just baby A. Okay? Alright, we talked about those. Now this is what's called a Pythagorean Triple. A Pythagorean Triple is any three numbers when you use your a squared plus b squared equals c squared. So if you've got this, and they're just telling us that we would have a 5, a 12, and a 13. Mine are not drawn to scale, obviously. So a 5, 12, 13 is considered what's called a Pythagorean Triple. They are exact digits, which means all the answers are whole numbers. They are not decimals. We also have another triangle called the 3, 4, 5 triangle, and any multiples of that. So 6, 8, 10. All of those are Pythagorean triples. Okay? Now, Pythagoras, depending on whether or not we're finding a short side or a long side, it is dependent on how we use the equation. So here's our basic Pythagorean equation. If I do not know my long side, I add the shorter sides and square them. So 3 squared plus 4 squared, 9 plus 16 is 25. Well, that's going to give me b squared. It's baby b here. I'm trying to find baby b. Well, that's equal to b squared. Do I want an answer of b squared? No. We need to square root the answer. So root 25 is equal to b. So 5 is equal to b. This is our 3, 4, 5 triangle. Okay? So your hypotenuse now, your triangles are given new names. The one across from the 90 is only ever called the hypotenuse. It's the longest side in any triangle. Okay. Now we're going to find your short side. That was fun. All right. We're going to find a short side. When we do this, we have to subtract. So 10 squared minus 6 squared, 100 minus 36 is going to give us 64. And again, that is b squared. Well, in this case, it is a squared, because it's baby a down here. So the opposite of squared is square root, so we need to square root. So root 64 is a, which is 8. All right. So we're either going to add to find the short or long side, or we're going to subtract from the long side to find the short side. All right. You guys can practice those ones on your own. Let's SOHCAHTOA. So, when we SOHCAHTOA, we come up with the SOHCAHTOA acronym this way. S, O on top of H, C, A on top of H, and T, O on top of A. So, that is why we call it SOHCAHTOA. In the fraction part tells you how to set up your ratio. That tells you what numbers you're either going to multiply or you're going to divide. It's one or the other. And by having them correctly in the fraction there, that tells you which button to push and whether you're multiplying or dividing. So, we are first going to find out what our three new names are. So we know hypotenuse is always the long side. But the other two sides of our triangle are called legs, and they've got two different names now. And we're going to call them adjacent or hypotenuse, or sorry, opposite. Adjacent means beside, touching. Okay? Now, the way you can remember the adjacent is always between the angle they ask you about, x, and the 90. So this guy's got to be the adjacent because he has to be between the 90 and the angle. And then the opposite is the one across from the angle. And that's how we label our legs to begin with. So the very first thing you do whenever you get a triangle, before you can identify whether you're solving for x as an angle or as a side, you have to decide what legs of my triangle am I given. And you have to label. So that's why labeling is always our first step. So let's take a look at our very first example on the next page. So we label our sides, just like we talked. This guy here across from D could be baby D. This guy is baby F, and this guy is baby E. So we're going to write our SOHCAHTOA, sine, cos, and tan ratios, by using these baby letters. So, our lowercase letters. Sine is considered opposite leg over hypotenuse. Now, we haven't labeled anything yet. First thing you have to do in the first rule of labeling is to find the unknown angle, or the angle they ask you about. So, this one they're asking us about angle X there, about angle F. So I would circle that guy. And now you have to label O, A, and H. Those are my sides of my triangle. So the H is the easiest one to find. He's across from the 90. He's the diagonal line. The other two are attached to the 90. Which one would we call letter E, the guy between the 90 and the other angle? Who's the letter E here? Adjacent. Good. And the other guy has to be the opposite. Perfect. Now, for sine X, I want O on top of H. So I'm going to put my opposite leg, letter F, on top of my H leg, which is letter D. Cos of X, cos wants A on top of H. So it wants your adjacent leg on top of the hypotenuse. So which one is your adjacent leg? Which letter in red? Baby E. And who is your hypotenuse?
H.
Baby D. H, yep. So tan is also known as O over A. Okay, opposite over adjacent. So who is our O leg in red? F. And who's our A leg in red? E. Good. So it'd be F over E. Okay? So that's the basics to labeling and to stating our equations. So this is the first part. You label everything. You identify what your equation is. Now you plug the numbers in when they give you a number here and there. So let's try the first couple. So we're going to find some angles here. Now one of the first things you have to remember when we're finding angles is we need to use the second button. Whenever we find an angle, we need to use second before we hit tan, or second before we hit cos, or second before we hit sine. Now again, it's only when we find an angle. So we would go second and then sine, cos, or tan. And then we would do our numbers. So we would go number, divide by, number, enter. And that's how we put it into our calculator. Now sometimes they do this part for us. They figure the fraction out for us, and they just ask us to find the angle. So they've divided the fraction and given us a decimal. And that's what they've done in this example down here. So we're going to jump down to this first example down here before we do example 1 and 2. So we're going to jump right to example 3. So I need to hit second sine and then type my decimal in. That's all I'm doing right now. So second sine and then type your decimal. And I want angle A. And then you do the same thing for angle P. Same thing for angle B, and same thing for angle C. Okay? Now, one thing you have to remember is your calculator must be in degree mode. So hit your mode button and make sure it's in degree. So just a reminder, you must be in degree mode. Okay, so now we can type in our numbers. So back to our main screen, I would type in second sine, and now 0.3584, enter. I get 21 degrees. We're going to the nearest degree. What you guys get for cos B? How big is angle B over here? How big is angle B?
57.
57?
Yes.
57 degrees. How big is angle P?
72.
72 degrees. And angle C?
30.
30 degrees. Perfect. All right, we're going to take a look now at question 1 and 2. Question number 2, example 2, whenever it's giving us the angle and it just wants the value of it, what it actually wants us to do is take our calculators and literally type in sine 81. You're not hitting the button second because you already have the angle. They just want to know the decimal number. And then math frac. What was the fraction they started with? So I'm going to hit sine 81, enter. And then I'm going to go math, enter, enter. Math, enter, enter. Oh, it didn't give me a fraction on that one. That's okay. But normally we would math frac it, so we would try to find out what ratio they gave us. What was the opposite side and what was the hypotenuse, because it was sine. So we get 9877. So 0.988, because it wants 1,000. So we have to round that third digit. All right, tan 14, what's our third digit for that one? 3 decimal places. 0.249. How about cos 44? 0.719. Is everybody confirming? Excellent. Everybody needs to practice. Okay, let's take a look at number 1. Number 1 wants the ratios for angle A. If it wants the ratios, it wants us to show the fractions that we would use for sine, for cos, and for tan. So we need to set up our SOHCAHTOA for example 1. So I'm just going to move it up, and I'm going to erase a couple things here. So, up here. So, for sine of angle A degrees. I want my opposite leg, so circle your angle. Now we have to label it. So, who's my opposite to angle A? What number's my opposite? 20, good. Who would my adjacent side be? 21, he's between the angle and the 90. And who would 29 be? Hypotenuse, good. So sine is O and H. We would have 20 over 29. Cos of A is a over h, we'd have 21 over 29. Tan of a degrees, what's O on A? So 20 over 21. Now what angle do we actually get for angle A if we use any of those? So now we'd have to type it in a bit differently. So now we're going to type it in with our second. So we're going to go second. So I'm going to type in second sine 20 divided by 29. So second sine 20 divided by 29. And you should get 44 degrees. Did everybody get 44 degrees? Okay, make sure you set it in correct. Second sine 20 divided by 29. Okay? Okay, let's take a look at the next couple. These ones, we're just going to write up the very first. Again, we're going to circle and label. Circle, and now we label. So we've got the H leg and the O leg. So if I only have O and H, what do I have to use? Sine. I have to use sine. So I'd have sine x is O on top of H. So this is where I'm going to hit my second button. Second sine, 4 divided by 6. How big is that angle?
42.
It is so. So angle X is 42 degrees. We're going to do the same thing to B. Circle and label A and H. With A and H, I need cos of B equals A on top of H. And I need to hit my second button. So second cos, 10 divided by 19. Practice with your calculators. Let's go. Don't be lazy. Write this down. So angle B, how big is angle B? 58 degrees it should be. Now what do you notice on the next question here? They give you all three sides. When they give you all three, you get to choose whether you get whichever one you want to use. Sine, cos, or tan, it doesn't matter. So on this one, I'm going to circle the C, and I'm going to label H, O, and A. We haven't used tan yet, so I'm going to use tan. So tan of C degrees is equal to 21 over 20. So I'm going to hit second tan, 21 divided by 20, and angle C is going to be 46 degrees. Check your work. The next question. The next question, looking straight to the next one. We don't have a 90-degree angle on the bottom, so we need to split it. Now, how do I know this is the case where I'm going to chop my triangle in half? Because it's isosceles. When they show me these two little points, that's meaning that these are both 6.2, okay? So we need to chop it right down the middle, and then we're given 90 degrees. Now, the question wants to know all of angle A. Well, I need to first of all find only half of angle A first, and then I double it. So we're going to have 6.2, and how big is my line on the bottom? 1.5. Good, because I have to take half of 3. Okay, so I just drew this other triangle right there. So, H and O. I'm given H and O, so what am I going to use? I'm given H and O. SOHCAHTOA. So you're going to use so, O-H. So, sine of x equals 1.5 over 6.2. And you need to hit that second button. So how big is half of angle A? Good. So angle X up here is 14. We need to double it to find angle A. How big is angle A? Angle A is 28 degrees. It's double of this guy. So it's this guy times 2 is angle A. Okay? Okay. I just want to jump to this page right here when we talk about angles of elevation and depression. This one follows our Z rule. If everybody can watch the Z to S rule, okay, that Z-S rule, angle of elevation down here is always equal to angle of depression, always, because of our Z rule. Now, one thing you also have to remember is angle of elevation and angle of depression always start from a horizontal. So, horizontal elevation will always go up from a horizontal. Depression, angle will always go down from a horizontal. So the angle of depression is here. So on a lot of triangles, when we do this, and they say your angle of depression is blah, 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 they're telling you from the top that angle. But the reason they're telling you this angle is because it's the same as that one. Okay, and they need you to remember that and identify it. Okay, the rest of the examples in this lesson are homework for you to do. We will pick up here tomorrow where we left off. Okay, you've had some time practicing this. So when we calculate side lengths, when we're not given any angles other than just the 90 degrees, we are resorting back to our Pythagorean theorem. Okay? Okay, so with our Pythagorean theorem, when we do this question, we're going to have the root of, because we have our special calculators, we can put them all in one step. So 3.7 squared plus 2.5 squared. And it'll find it for you in one step. Okay? Now, a way to confirm that you did it correctly is to make sure that you've got a number that is bigger than the other two numbers. Because remember, we're finding the longer side. Now, what if you're given an angle? We discussed this. So if you're given an angle on one side, basic few steps again, is we're going to circle the angle and label each side. Hypotenuse and opposite we're asked to find. So you would use sine, so sine of the angle is equal to x over 14.2. And as we discussed, whenever x is on top, we take the number off the bottom, pull it out front, and multiply it. So in our calculators, you have to always remember that the number on the bottom is always being multiplied to sine 52 in this case. So we're going to get x is equal to 11.2 centimeters. Now again, it should be less than 14.2 because we did find a shorter side. Okay, let's take a look at the next couple examples. So this is the one on top. We want to find the length A to B. This guy here, we're finding x, circle our angle, pardon me. So this is going to be our opposite side and adjacent side. So we need to use tan this time. So tan of 71 degrees equals x over 147. Again, x is on top, so the number off the bottom comes out front and multiplies. So we're going to get x is equal to 147 times tan 71. We're going to get 19.5. Oh, pardon me. That was the answer for the next question. Okay, so we got the right question going on here. So we got the answer is 426.9. To the nearest whole number would be 427 meters. Let's take a look at the next one. So we circled this one. We are being fined C to D, so we're asked to find our hypotenuse in this case. So we're going to label, we have our opposite and our hypotenuse. So we're going to use sine. Sine of 38 degrees equals 12 over x. Now in this case, when x is on the bottom, this is where x and the left side of our equation literally switch places. And that's how we end up dividing. So it's going to be 12 divided by sine 38. And yes, you hit the button sine. So that is going to give us 19.5. Okay, so it's going to give us 19.5. Moving on, we discussed angles of depression and angles of elevation earlier. Let's take a look at how you drew the triangle. So we've got our tree. Here's our tree. And it's casting a shadow. He's 5.1 meters tall, casting a shadow 7.5 meters long. The shadow is always on the ground. It is never in the air diagonally. A lot think the shadow is the diagonal line. It is always on the bottom. So it says calculate the angle of elevation. So this is our angle of elevation. That's what it wants us to know. To the nearest tenth of a degree. So we're going to circle the angle they want. This is our opposite and our adjacent. We are going to use tan. So since we need to find the angle, I always write to myself a little note. Second tan, so I remember to hit the second button. Opposite, 5.1 divided by 7.5. So in the calculator, you're going to hit the second button first. Second tan, 5.1 divided by 7.5. You're going to get the angle of elevation is 34.2 degrees. Check your work. All right, carrying on. You also have the ladder question to do. The ladder against the wall. The ladder is 4.5 meters long, so this is our ladder. So he's 4.5. It says the angle between the ladder and the ground is 65. Okay, there's 65 degrees. And it says determine the distance between the bottom of the ladder and the wall. So there's our x. So labeling again, this is our adjacent side and hypotenuse. So I need to use the cos button. So I write it with my equation, cos 65 equals x over 4.5. Now, just like we discussed earlier, if x is on top and the number's on the bottom, you're going to take the number out front and multiply it. So, in this case, we're going to get x is equal to 1.9. So it is 1.9 meters away from the wall. Now, when we spoke about triangles that were joined, whenever you're talking about triangles that are joined, you always need to find the side that they join by, if they don't give that to you already. So let's label everything they tell us. So Q to S is 32 millimeters. PQS, so P to Q to S, so that's this angle right here, is 50 degrees. And that means this guy up here has to be 40 degrees. The reason it has to be 40 is every triangle has to add up to 180 degrees. Angle R to P to S is 61 degrees, so that guy's 61 degrees. And I can find out angle R by going 180 minus 90 minus 61, and that's going to give us angle R. Now, we need to find Q to R, this whole length. So that means I need to find this part first from here to here, and then I can add it to the 32 I already have. But first of all, remember, they're only going to give me 2 out of 3 numbers. So that means I need to find this number here first, the number they're joined by, the side they're joined by. So I'm going to find side Y. Well, if I label my first triangle, so here's my first triangle on the right, I've got 32 and 50, and I need to find Y. Well, in this case, here's my angle, he's my opposite and adjacent. So to find the side they're joined by, I'm now going to take tan of 50 equals Y over 32. So Y will be 32 times tan 50. So we're going to get Y to be 38 exactly. It's going to round. So it is exactly 38. So now I know this number's 38. So now on my other side, on my other triangle, I have a 38 here, which is y, and then I've got the 61 degrees. I can find x, and then I just have to add it to that 32. So if I label my triangle on this one, I've got my adjacent side and opposite side, so I'm using tan again. But this time it's a different angle. So tan of 61 degrees is now x on top of 38. So again, x is on top, so I'm going to take 38 times tan 61. And then we're going to find x is equal to 69. So x equals 69, and to get the full distance, you're going to take 69 and add it to 32. So 69 plus 32 to give you a distance of 101. And that is your distance from R to Q. Okay, you've got a few bits to work on this. Let's take a look and see if you labeled your diagram correctly. So you have a guy wire, and it is 13 meters, and it's attached to an 11-meter pole, and you need to find the angle. So hypotenuse and opposite, so you're going second sine 11 over 13. That's going to give you our missing angle, which is 58 degrees. Now we need to find how far it is from the ground. That is our next thing to find. So that is labeled x. So now we are taking sine of 58 degrees is equal to, sorry, it's not going to be sine, it's going to be cos. We could use cos or tan, just not sine, because we have to find the adjacent. So adjacent x over 13. We're going to have x equals 13 times cos 58, and x is going to equal 6.9 meters. Okay, let's turn the page and check how you did on the next section. So again, you have to label correctly. You need to find the unknown side. So the unknown side should have been 7.2, and then you had to find your unknown angles. So this angle down here, the angle F, you should have found is 47 degrees. So if you labeled opposite adjacent, you should have tan of F is equal to 5.3 over 4.9. And again, you're hitting the second button first. And that's going to give you your 47 degrees. Once you find angle F, you can find angle D by taking 180 minus 90 and 47 to give you 43. Let's take a look how you did on the bottom of the page. Again, we have another joined triangle. When we have a joined triangle, we need to find the side they are connected by. So we are taking our smaller triangle, 50 degrees, 11, and we need to find the side they're joined by. So labeling, we have our hypotenuse and our opposite. So sine of 50 degrees is equal to x over 11. Now we're going to take 11 times sine 50 to give us x is equal to 8.4. So now we know this is 8.4. We're going to take a look at the giant triangle that is 40 degrees. These long numbers are no longer existent for us, so we're finding our hypotenuse. That's our question we need to find, and then we need to use this guy who's our opposite. So sine of 40 degrees equals 8.4 over h. This time is the swaparoo. We're going to divide. So the hypotenuse is 8.4 divided by sine 40. Okay, we're dividing again, guys, because the unknown is on the bottom. So when you divide, we're going to get h is equal to, so we should get 13.1. So the hypotenuse is 13.1 meters. Okay, last couple questions here. So, or question, I should say. First of all, you need to find, it says the transit is 52 meters from the base. The angle to the top of the tree is 12 degrees, but the transit is also 1.8 meters high. So we need to determine the angle of the base of the transit with the tree. So this is what we need to find out, is that angle there for letter B. But we are not able to find that out until we find the height of the tree. So we need to find the height of the tree first, x. So as we're finding height of the tree, we label our diagram. I'm just going to take this off first because that's for part B. So we label 12, we have our opposite and our adjacent. So tan of 12 degrees equals x over 52. Unknowns on top, the bottom will come over and multiply. So x is equal to 11.1. Okay, so we've got 11.1. Let's just check our work. Okay, so we got 11.1, but that's not the total height of our tree. That's only from where the equal for our transit is. So we need to add the height of our transit, which is 1.8, to get the full height of the tree. So plus 1.8, our tree will then be 12.9 meters. So now we know the height of our tree. So we can redraw the triangle for the next section. So our height is 12.9. We have 52, and now we want the angle with the ground. So opposite, adjacent, we are using tan again. So tan of the angle theta we don't know is 12.9 over 52. And in this case, we are going to get angle theta is 14 degrees. So it is 14 degrees with the tree and the ground. This concludes lesson D.